Hi. In our last video, we added some additional comments for what is essentially feature creep, but just ways to make this program a little bit more efficient and a little bit more interesting, a little bit more advanced. So I just want to go through these bullet points one by one and add some new features. The first thing I had is that when we look for tiles while actually displaying them, we have the tile name and we have to figure out which image is associated with that name. The way we do this right now is by searching through the entire data model by name, and that can be quite slow. So what I'd like to introduce is a tile LUT or an index, which basically maps the name to an integer using a dictionary, which is a lot faster. So this will just be a lookup table where we give the name and get a number, and then we use that on the data model. But let me just implement the logic here real quick before we actually do the plumbing to actually get this lookup table. We just get the tile name. We use the get function because we're not sure that this tile name exists. I mean, it should, but rather not have errors. And then we get the tile index. And if the tile index is none, then we continue. And that deprecates this bit of code. And then finally, the tile item is obtained from the tiles model. And then we just get the item at the tile index. And that's all we need to do to change this logic to use a lookup table. Now we had the level renderer, which is a subclass by level editor. So we need to do some plumbing here where we forward that tile LUT. And then where we create the level editor, we also need to insert that tile LUT. And now let's actually build the tile LUT. So this lookup table will just be a dictionary, and wherever we create a QStandard item with a specific name, we can also register the name in the dictionary, and we need to know which row that is in the table. Now currently, the table, we always append at the end. So we can take the row count for this. So if the table is empty, this is 0, then we append a row. So row 0 will have the item with this name. And that will just perpetually work for however large this table grows. Let's just make sure that this starts up, and it does. You might have noticed that I try and just have fun with optimizing things and making them a little bit more complicated than when they first were. Of course, all of these things are optional. I first try and get things to work, and if I have time, I try and make them better. Usually you don't, because there's so much to do, so you just grow and grow and grow your product until you reach a point where you really need to optimize this drawing thing, because looking up every tile by name does get slow as we get more and more tiles and we're drawing more and more tiles. Similarly, if we had a very large map and, for example, the ability to scroll this window, so we could really have a gigantic map that doesn't fit on your screen, then drawing all of the tiles would be way too slow. So then you could think about optimizations like let's only draw the tiles that fit inside the viewport, which you can detect when you can scroll the viewport. You have to figure out which rectangle is actually on the screen, what are we going to draw, and then make sure you only draw that. That's that kind of optimization you can add whenever you need, basically. And for now, I think that's a little bit too complex to tackle. But in essence, it's something you could try and add yourself. And it's similar to this tile that I just created, but that's a simpler optimization. So that's more bite-sized and that fits in this video, I think. Now next, I need some transparent assets, which I don't have an image editor that supports transparency. So I'm gonna hack my way with QImage. This is gonna be a little bit Python 3 specific, and if you have a transparent image editor, use that, please. But I'm just gonna have some fun with this, because why not? Because with Qt, you can do your imports, you can create your application. Let's actually just copy this. And then you can actually use QImage to load an image. So I could go into tiles and load grass.png. That's an image. And then image has a bits function. And if I print that, that gives us a memory object, which is new in Python 3. I'm not sure if we can index with that. Yeah, we can. So we get bit 0 or byte 0, byte 1, byte 2. And these are, I think they are their individual color components. So you have alpha, red, green, and blue. Or you're not guaranteed that is the case, so we can say convert to format. So a QImage could be grayscale, could be RGB, could have alpha, could not have alpha. So we're just going to convert this to format ARGB32. And what that means is that we have 32 bits, but 1 byte is 8 bits. So we have 4 values per pixel, which are alpha, red, green, and blue. I think in that order. It might be the opposite way, so we'll figure that out as we go. And then we can edit those values. So I could say the alpha of the first pixel is going to be 0. Let's see if that works. Invalid type for format B. Oh, that's a float. That's my bad. And then we could save the image again. So let's have a little test image so we can actually inspect whether what we're doing is correct. All right, that image seems lacking red, so I think index 0 might be red. Or no, it's yellower, so it's lacking blue. So it is the opposite way around. I think it's blue, green, red, alpha. That's what we're looking at. We can of course test that by saying blue, green, alpha. So we have a opaque pixel that is black. Yes, and now it's gonna be red, I think. Yes, now it's just gonna be gone. That didn't work. Why didn't that work? Oh, I'm converting to format, but not properly. This returns a new Q image, and I forgot to assign the variable. So now I have an RGBA image, and now it's transparent indeed, as expected. And let's see if this is still opacity. Yeah, okay. So this, what I was doing before was just editing the next pixel over, which of course we shouldn't have. So this is a script that we could use to change the bits, and we can get the color of every pixel and then see, I'm gonna hard code a specific color and say if it's this color, then I want to change it to transparent. And one other thing I'd like to do is reuse some code here. So I'm gonna create a new file. It's just gonna be like utils.py because every project needs a utils file. It's just, I don't know what to call this file. And then we have this part where we loop over all the tiles, and I just want to loop over all the tiles and make certain colors transparent instead. So I'm just going to copy paste this logic where in my utils function I'll have a scan tiles function. I need import OS. I'm going to find the tiles folder still in the same way. Then we get the name. We can skip it if it's not a PNG. Then I'm not going to build a model yet, so I've got my name and I've got my tile path, which I want to return. And then the other logic for building the actual data model is still going to stay in the main file. So I can say import utils as I did, and then scan tiles, and then it's for name and tile path in scan tiles. I want to create the standard item. I don't need that tile path line of code anymore. But it should work the same way. Let's just make sure that that happens. Yeah, it still boots up, still draws stuff. I'm happy with that. So now I can use that same function here, where I just import utils, and then for name, tile path in utils scan tiles, I can open that tile path and convert that to format, and then I have my image. And then for every pixel, and I think I talked about this before, good habit to have, iterate vertical before horizontal, and in this case it actually will matter because we're dealing with binary data. For y in range, image.height, and then for x in range, image.width. So first y, then x. That way we lean into the strengths of how our hardware works, and we access the bits in a specific order. So I've got my binary data, and then I've got my pixel ID, and we actually have 4 channels as well. So for channel in range 4, I guess we could do that. I think I'm just going to hard code this. So my pixel ID equals x plus y times image.width. This is how you can translate from a 2-dimensional coordinate to a 1-dimensional coordinate. If you know the width and the height, you can go I have an X and a Y, and I want an index in the list that is all of these pixels. And because we have RGBA, we need to multiply this all by 4, so we have the actual offset into the array where we have 4 channels every time. And then we can do plus 0, 1, 2, 3 to get our blue, green, red, and alpha channels. And then I could say if red is equal to 255 and green is equal to 0 and blue is equal to 255, then I'm going to set the alpha to 0. And actually a nicer way to do this in Python is to say red, green, blue is equal to this tuple. Just reads a little bit easier. Set alpha to 0. And then finally we just save that image at the same path that we found it. We could even have a little Boolean flag that tracks whether we change the image at all. And then only save if it has changed. And maybe make a little message of that. Changed this file. Right, and now I have the ability to go into Paint. Let's copy this file path because I'm pretty sure it's not going to save in that folder. Oh, it is. Cool. And then I'm going to make a little flower asset, for example. And then I'm going to create a color that is that 2550255. Fill it up. Now that's going to become transparent. And then I can have like a nice little yellow flower petal thingy going on. With a blue stem for some reason, because else it will have the same color as the grass and then it's not readable. So I run the script. It should change my flower into a transparent flower, as you can see here. In PyCharm, we can view the image properly and we can see that it's transparent. And then if I go to my main application, I have my flower asset here, and I can actually place that down in the scene, and it stacks nicely. It has transparency. So we built all this functionality already, but I just needed the assets to prove it. And I thought this was a nice little detour to how you can use Qt to do image processing. Be warned, it is very slow to do everything per pixel in Python. It's not a good strategy for processing images, lots of images, large images, but it is a great way to learn about image processing. So if you ever wanted to mess around with pixel data, this is a great way to access that pixel data. All right, so now let's make a larger asset. So I'm going to make a, not here, make a new file, and it's going to be taller, 64 pixels, for example. I could maybe even just do a very big square image. I am going to change the colors around a little bit so you can distinguish this from the background. Of course, Paint does this anti-aliasing thing. Very nice. That's better. Gonna make some blobby tree shapes. And then I need a trunk underneath that. That's a very ugly red. The idea is that the bottom square here, this area, will be on the tile, and then everything that sticks out will be automatically positioned based on the size of the image. We're just gonna try and be smart about this and place the tree in a good position. You know, you get the point. That's good enough for me. And then finally, let's get that background color again. And the reason I choose this hideous color is because it's very unlikely that you will actively use this color, because if you're an artist, this is not a color you want to use. Let's be honest. So I run my image transparency script again. seems to have changed the flower again somehow. Not sure why. Interesting. Anyways, we've got our transparent little tree. And now if we go into our tile editor, we select our tree and we place it somewhere, it's going to be, well, it's going to be overlapped by the other tiles, which is interesting in and of itself. And it's going to be in the wrong place. So let's try and move this tree so that the center is on this tile. Save that out. We have our test data. We now need to figure out how we align this asset properly. I think it will really just be a renderer problem. So I might want to pre-compute some of this information so we don't have to think about this every time we draw an image. So when building the model over here, we load that image. We can take that image width, take that image height. We can subtract the grid size. Where was the grid size? Level renderer. So this is kind of the excess that we're sticking out on the right and on the bottom. And this is how much I want to move up, offset Y. And I'm going to move only halfway to the left. So if the image is very wide, it's centered on the tile. It's not has the bottom right corner on the tile. That would be different. So I'm just going to take this value and divide it by 2. And then really we can just set that as another item data, another user role. So let's just call that pivot or something. Right, and we just store this tuple in the item, and then when we're drawing, we get not only the image, we also get the offset that we just stored here, and we can add that back in, or I think we need to subtract that actually. Yeah, that looks better. Got my tree, and well, I place that, it's centered on the tile. So that's exactly what I want. This is not what I want, but then we would need to have meaningful knowledge of which asset is transparent and which isn't. So not so hard. You can like slowly grow features and add complexity to this as you go, which I think is fun. It's fun to make little projects like this and then think, what do I want to do with it? You might think, I want to add animation to this, so maybe we'll have support for files with numbers in them and then automatically cycle them on a timer or something like that. Not something I'm going to do today, but it's those kind of features you could add. One final thing, I mean, all of this was polished. I'm just going to remove that. One final thing is the file dialog. So when saving and loading, I hard-coded the file path to illustrate how easy it is to save and load stuff. But really, Qt has some other cool features that help us allow the user to choose where to save and where to load. One thing I'm going to do is remember which file is open. And I think I call open somewhere actually. Yeah, right there. So current file is none. Now when we open, there's a point where we load this level. So then we can say self with current file is level.json. And then when saving, I'm going to use that current file instead of the hard-coded level.json. This is going to get better in a bit, trust me. We'll also add a save as function, which opens a Q file dialog that gets save file name. That takes a parent, which is us. It takes a window title, which is save, and it takes a location, I believe, and it takes a file format. So I'm just going to put level files start.json, and then that gives a result, and the result is always a tuple of 2 values, or in some Qt versions it can be none. So I always check it, like if we don't have a result, then we don't want to save. The user click cancel instead of OK. Or if we don't have a result at index 0, then that might also happen. That's a difference between PyQt and PySide, I believe. But either way, this catches all of those Qt version differences. And with this check, you are 100% sure that this is a file path that we want to save. So we could say our current file is this path, and then we can say self.save. And it's going to save at the path that we just clicked on. And here we can say, if we don't have a current file, that would be an error, but we can just redirect the user to save as. And then the user can still click cancel and it would, not save at all. Or it could save the file to a location and then save gets called again, and then this if check won't fail, or it will fail, so we will just go into the normal save logic. So saving is now sort of agnostic to which file we're saving. I'm going to add a save as action as well. Save as, and I think that would be an E right there. Save as. And then when opening, we can do the same trick where we have a new file dialog get open file name. And that's also, we are the parent of that file. We have a window title, or we are the parent of that dialog, sorry. And we get a window title, we get our file path to load from or to start browsing in. And then we can just say what kind of file are we looking for. We're looking for level files, which are JSON files. And then the result works the same way, so we can just cancel out of that. And then we are sure we have a current file, so we can set that current file. We can load that current file, remove all of this stuff, and then we're back in action. So this automatically pops up the open dialog because I call the open function. And if I cancel, I get an empty project. So I think I'm going to do that instead of calling open. I'm just going to, have a new blank file, like most software when you open Notepad. It's a new untitled file, which actually brings me to the fact that we could also change the window title. So we could have something like this. And we could, whenever we set the current file, we could update that. That could be fun. Right, so this is untitled. Well, it's none in Python, but whatever. Good enough for me. We open the level and it says, here's the level. That's a little bit verbose actually, so maybe just get the base name. But it's a little bit shorter. And let's actually make a function of that, so that we don't have to copy paste this and then we change it. So that happens over here, and that happens over here. And then of course I can't get the base name of none, so this is breaking right now. So let's just change that to be untitled. And then we can open our level. We can save our level. Also save our level as. I have level 2. We can erase some stuff, save that. Hotkeys should work, by the way, so let's just double check that. I have my level, which was not erased, and I have my level 2. So I pressed Ctrl S there out of reflex, and I'm happy that I put these hotkeys in. I noticed that the save as action on Windows actually doesn't have a hotkey associated with it. I think some applications do like Control Shift S, which on OS X would be Control Command S or something. And we could, of course, change the shortcut manually when we're on Windows. Let me just check how to get the platform again. I think I want to press Control Shift S to save a new file. So I'm gonna construct a queue key sequence that is Control plus Shift plus S. Right, so just on Windows, we're gonna change that from the default hotkey. We can Control O to open. We can Control Shift S to save as. Control O to open. And then Control S to save. Whatever we want. I think that rounds up everything I wanted to talk about. I hope you learned some cool new things about Qt and image processing, even though image processing is really not relevant to what I was creating, but I felt it was fun to talk about. So I hope it was interesting. Thanks for watching.